All right, so what is the difference between gabbro and basalt? Okay, so what was that? The texture. Okay, so one thing, gabbro is coarse, basalt is fine. That's not the only difference. So what's another difference, Trey? Yeah, you could talk about, so where are we? Gabbro is intrusive, basalt is extrusive. There's probably a couple of more correct answers. Anybody else have another one?
Crystal size.
Yeah, crystal size. So gabbro has 1 to 10, basalt has less than 10. No, never mind, that's a similarity. So I think those are the three differences. So crystal size, texture, and environmental formation are the three differences for gabbro and or basalt. So then what would have caused those differences? This might depend on how you answered. So Trey, you answered their environmental formation, right? What did you say as what caused that difference? So that's what you wrote here for explaining the difference? Okay, so the different, I'm good enough, you know what you mean. But what causes the different crystal sizes, for example?
For the cooling speed. That's what
Yeah, crystal size, and actually crystal size and texture basically are the same thing. And that would be their cooling rate. It's the only thing that's different about them. In fact, the next question is, what do they have in common? What do basalt and gabbro have in common?
dark color.
They are both dark color. And as long as we're here, they all have a high density and they both have the same composition, meaning they're both mafic. They actually even have the exact same minerals as well. And also they're all, both of them are non-vesicular. So basalt and gabbro have a whole bunch of stuff in common. Truly, the only thing that makes them different is how fast they cooled. Gabbro cooled slow, basalt cools fast. And that has to do with their environment of formation. If they formed extrusive, they cooled fast. Intrusive, cooled slow.
Was there a way that they both like look exactly the same?
They wouldn't look exactly the same because their crystals would be different. So they could look exactly the same, just have different size crystals.
But it's on the intrusive side too.
No, basalt is extrusive.
Oh, basalt. Yeah.
Yeah, basalt and gabbro. One's intrusive, one's extrusive. So I didn't pick diabase for that reason. Yes, diabase and gabbro are going, I would never give you both of those and say, tell me the difference. Because yeah, you as 10th graders wouldn't be able to. I don't think I could as just a teacher either. All right, so we went through what they have in common. Again, color. You know, I don't think I need to write this. Color, density, composition, any of that stuff would be good. So what's the biggest difference between rhyolite and pumice? Somebody else, because I've heard from a lot of the same people. Nope, not you. Yeah, Logan, what are rhyolite and pumice? Say it again. Yeah, rhyolite is non-vesicular. Pumice is vesicular. There's other answers though. Yeah, their texture or crystal size. So pumice is glassy, which means no crystals. Rhyolite is fine, which is less than 1 millimeter. So any of those would have worked. Which one's vesicular, rhyolite or pumice? So we just went over that. Yeah, so pumice is in the vesicular group. There is a vesicular rhyolite, so just make sure they will specifically say vesicular rhyolite if that's the one they want. So it goes back down to reading. What is the characteristic of the rock that is 100% olivine? First off, which rock is 100% olivine? Yeah, see, don't forget about these two that are squeezed in over here. Dunite is just 100% olivine. And then hopefully you see that it's on the higher density, darker color, and by composition, they just wanted you to write that it was mafic. All right, so how about name that rock? It's glassy, vesicular texture, and dark in color. No, yeah, not rhyolite. Rhyolite's light in color. That one is scoria. Which one is this? I'm sorry, felsic, non-vesicular, grain size less than 1 millimeter. That one's rhyolite. Which one is glassy and may appear black? Obsidian. Did we talk about that one yesterday? Obsidian's a weird one. If you notice in parentheses underneath the word obsidian, it says usually appears black. So a lot of people are like, well, why is it on this side then? It is on this side of the chart because even though it appears black, so it doesn't fit the color section, it fits everything else. It's made of these minerals. It is felsic and it has a lower density than something on the left or the right side of the chart. So they do give you that note. So don't let that trick you up. Obsidian appears black. Okay, so letter D, name that rock. It's mafic, coarse grain, contains pyroxene and olivine only. Yeah, periodite. Don't worry if you guys are not able to pronounce these. think I'm faking it with most of them, so don't worry about it. E is felsic and very coarse texture. Not very coarse. Pegmatite.
Oh wait, I was looking at the wrong thing.
Okay, good, because there's really no way to confuse those two. This one, fine grain, non-vesicular texture, and is high density. That one's basalt. And intrusive, light colored, coarse texture. That one is granite. Questions on that? Perfect. Did we go over the answers to the top half of this yesterday? Okay, so just making sure your answers to the top part here, if they were just 5 off from mine, either way, 5 less or 5 more than mine for either one of them, you're close enough. I do want to point out that if your mark doesn't hit right on a 5, like 5, 10, 15, or 20, you probably should be estimating. So if it's halfway between the 15 and the 20 mark, somewhere around 17 or 18, and that is a thing. So you do need to estimate as close as you can get for those. All right, we've got actual regions questions here on page 21. These questions back here are great. And you really need to be able to do all of this to answer these. But these are how the questions are going to be worded, by the way, on your quiz on Thursday. Quiz on Thursday on just igneous rocks. It will be 10 questions or less. So it's just going to be a quick 10-question quiz. This was about 10 questions there that you just did. So about that much time, we're going to keep going with sedimentary rocks after that. But this is what the questions will look like on Thursday. So make sure you're able to get through any trickiness that they might do with their wording. We got which one? A characteristic of rocks that are high density. So if they're high density, they're over here. What else do they have? Which answer? 1, 2, 3, or 4? It is going to be, so I'm seeing a couple different answers. So if they're high density, they're going to be mafic. So if they're mafic, they are also dark in color and they contain iron and magnesium. So that's answer number 4. As the percentage of mafic minerals in an igneous rock increases, the rock's color, and it also looks like we're going to be, so what happens to the color? As we get more mafic, it means we're going this way. What happens to the color? They get darker. So process of elimination, I'm getting rid of the lighter answers. So now we're looking at, are they darker and the density is higher or lower as we get more mafic? Yeah, density is higher. We're going over on that side. Which rock is felsic composition, low density, light color, and coarse grained? The answer, 1, 2, 3, or 4. Yeah. Coarse grain is the kicker there. So coarse grain is going to be granite. Which statement is true about granite and gabbro? So granite and gabbro. What one did you pick? 1, 2, 3, or 4. We're on question number 4. Okay, I'm seeing mostly the right answers. I am seeing 2. They are both intrusive, so that is true. But I did see a bunch of you that said they both contain potassium feldspar. So potassium feldspar is this one right here. Only granite's going to have potassium feldspar. Gabbro is going to have a boatload of plagioclase feldspar, but no potassium. So that's why answer 2 is wrong for those of you who are putting that. So don't get your feldspars confused. Read all those letters. Which characteristic of an igneous rock would provide most information about the environment in which the rock solidified? 1, 2, 3, or 4. It is going to be the texture. Remember, texture just describes the crystal size. So crystal size would have been a good answer, but that wasn't on there. So texture and crystal size go together. The Regents loves putting questions into bar graphs. I think I found one on every single test so far this year. They love putting simple stuff into graphs. Which one is true about the crystal sizes for basalt, granite, and rhyolite? One thing I did, just to be clear, I went through and I looked and I saw that basalt was fine, granite was coarse, and rhyolite was also fine. That's one thing I did, so I didn't have to think multiple times. So for me, the kicker is that rhyolite and basalt have to be the same. So right away, I can get rid of that one. Okay, that's the only one I can get rid of. But fine is smaller than coarse. So hopefully you picked answer number 3. Larger crystal size in one of 2 igneous rocks of similar composition usually indicates the rock with larger crystal size cooled for, which answer did you pick for the number 7? I'm seeing it. Answer 2, if we got larger crystal sizes, we cooled longer. The longer it cools, the more time they have to sit around and grow. Larger crystals in an igneous rock most likely are a result of, again, we just went over that, the cooling rate of the magma. Number 8, which property is common to most light-colored igneous rocks? So remember, if we've got light color, you also have a low density and your felsic. So that is answer number 3. Property common to most dark color. So it's the opposite now. We're dark. They're going to have a higher density and they're going to be mafic. So for question number 10, the only one that fits that is high density. 11, compared to basalt, granite is. There's a lot of differences, but of the 4 answers, only lighter in color will work for granite. Rhyolite and granite are the same as they are both. Rhyolite and granite, they are not both fine grained, so not one. They are not both dark colored. They are not mafic, because that would be over here. So hopefully they are both felsic. Yes, they are both on the felsic side. Number 13. What'd you guys get for 13? Which relative concentration of elements are found in felsic rocks? Which one did you pick for felsic? Okay, I'm seeing a couple different answers, but felsic is going to be number 1. So just to be clear, if they're felsic, am I right? Yeah. If they are felsic, they're going to have silicon and aluminum. Mafic is iron and magnesium. So going through, they will not have a high concentration of iron or a high concentration of magnesium or another magnesium one. Process of elimination is really going to be your friend with these questions. Read all 4 answers and cross off the wrong ones. Good? Yeah, what's up? No, iron is Fe. So that's a good question. That's one thing that they did to be jerk faces. Aluminum, they gave you the words instead. So if you don't know where to find them, flip over to the back. So aluminum is Al, so that could have been one thing you did. And iron is Fe. So that might have helped if you labeled them. And I like labeling. I like crossing off. Those are all really good test taking strategies so that you don't overthink questions. If you labeling them, you don't have to think about them more than once. Mafic rocks. Again, if they are mafic, they are on the right side of the chart and they're going to have high density and dark in color. Best evidence for determining the cooling rate of an igneous rock during solidification is provided by, which answer did you pick? How do we know if it is how fast it cooled? By looking at it. Which one did you pick? I am seeing the right answers. Crystal size, answer 3. And finally, as the hot molten rock material, which is magma, cools, the size of the crystal and the igneous rock form depend chiefly on what is going to control the cooling or the crystal size. I think I just said it. It is answer 4, the rate at which it cools. I feel like I just went fast. Are there any you want me to go back over? So this is the type of questions you can expect on the quiz on Thursday. So they will just be old regions questions. So ones just like this, maybe even a few of the same ones, or I might change the words a little. So make sure you read carefully. You sure you don't have questions? Okay, then I guess we'll move on to sedimentary rocks. Only have a little bit of time, so we won't overtax our brains. First of all, from the rock cycle, how does a sedimentary rock form? You remember? Oh, no, I thought you were memorizing it. Go ahead. Say it again, Riker. So for a sedimentary rock to form, any rock, whether it's an igneous rock, a metamorphic rock, or another sedimentary rock, has to go through weathering and erosion and turn into sediments. Then what happens to the sediments? They get deposition and burial, then compaction and sedimentation into a sedimentary rock. In other words, we get rocks that break into sediments, sediments that get deposited, buried, compacted, and cemented together. All sedimentary rocks form that way. However, there's a lot of differences with sedimentary rock. So we are over here on page 7 of our reference table. There are, 10, 2, 4, 5, 10 sedimentary rocks that we're going to be responsible for this year. They won't ask you about any others. And just like the igneous rocks, just like the minerals, just like your bird beak stuff, this is another dichotomous key. Works through itself, I think, a little bit more straightforward than the igneous rocks, but there's some things on here that I'm guessing you've never heard of, and that's right where we're going to start. We're going to start with these terms called clastic, crystalline, and bioclastic. They are listed as the texture. So just like on minerals, the first thing we looked for was their luster. And on igneous rocks, the first thing we looked for was intrusive or extrusive. The first thing we're going to look for on sedimentary rocks, is their texture. And once again, texture is not how they feel. Texture is how they look. But do these words mean anything to you? Clastic, crystalline, and bioclastic. Probably not. Maybe crystalline. Could you figure that one out? What do you think they're made out of? Crystals. There. You guys know something already. There's a hint, though. They give you a hint for clastic. Can you read it? They're fragmental. What are fragments? Little pieces. So clastic sedimentary rocks are the rocks made from broken pieces of other rocks glued together. So clastic are rocks made from broken pieces I guess I'm going to go with cemented instead of glued. So these are more like what you think of when you read right off the reference table about sediments getting deposited, buried, and compacted together. Crystalline, like you guys said, these are formed from crystals created by chemical action. And then I bet you can now put together the word bioclastic for the last one. When you hear bio, what do you think? Living. And now we know that clastic means fragmental. So what do you think? Could be bones? Any other things that it could be? Shells are the other one. So bioclastic are formed from the remains of once living organisms. So those are just the 3 different types of sedimentary rocks. The next box over is grain size, which just means how big the pieces or crystals are. So we're going to go with grain size. Composition. You know that one? What they're made out of. So if you look down that column, you'll see that the whole top half of the chart, they're made out of a mixture of stuff. The whole bottom half, they each have their very own distinct composition. What do you think the name of the rock is? Yeah, it's the name. And the last box is the comments. Looking down the comments, conglomerate has rounded fragments. Breccia has angular fragments. So in that case, it's just telling you a little bit about the rock, a little bit of observations. But if you go down further a little bit, so here it's talking about fine to coarse, very fine grain, compact, might split easily. Here they tell you they're crystals from both chemical precipitates and evaporites. And here they're telling you they're made of cemented shell fragments or compacted plant remains. So what I like to say about the comments is it tells you a little bit about the rock. And then I always add, it may help you identify the rock. So the rounded versus angular will help you. The may split easily will help you. Made of compacted shell fragments will. But knowing how they're formed, that's not going to help you identify it. So we're going to start using this rock chart tomorrow. So it's great that we got the notes under our belt and we will come back and use it tomorrow. And again, you have a quiz on igneous rocks on Thursday. No homework tonight, in case that wasn't clear.